All right, so let's pick up on these last couple of parts to this question, and then we'll jump into the last bit of examples. So we still have order of operations that we're doing here, but now we got a big old fraction bar. So remember, anytime you have a big old fraction bar, you want to tackle everything above it and below it first. And we still got to follow those rules when we're simplifying the top and bottom. So, okay, we got parentheses with something to do. We have multiplication. We got parentheses with nothing to do. And then we're dividing by something with an exponent. Okay, and then the bottom is just a subtraction. All right, we can do that quick too. So it looks like we want to do parentheses. Can't multiply, can't divide because there's that exponent we got to tackle, and then on the bottom. All right, so negative 10 plus 4. So we want to subtract, really. So 10 minus 4 is 6, but the 10 is bigger, so that's a negative 6. So we got negative 6 times the 6 divided by 2 to the second power. So that's just 2 times 2, so that's just 4. And now, negative 7 minus 2. So remember, if you're at 0, we want to go back 7, and we want to go back 2 more. So we're even further into the hole. So we're really at 9 in the hole. So negative 9. Okay, so not too bad. So now we got multiplication, and then we got division. So which one do we do first? Hopefully you're saying from left to right, because that's what you got to do. So we want to do that multiplication first. So negative 6 times negative 6 better be positive. So positive 36, so we don't need any parentheses. Divided by 4 all over negative 9. All right, so now we can do that division. So it looks like 9 over negative 9. So what's 9 divided by negative 9? Well, we better get 1, but it should be negative because one of them is negative. All right. Now this last one really has a lot of yuckiness to it, but we can do it. So we got multiplication, we got addition, we got another multiplication, and then we got something with an exponent, we got another thing with an exponent. Okay, so we want to be a little careful here. This stuff with exponents can be deceiving. Some of you are looking at this and saying, oh, well, that's just negative 2 times negative 2, which is positive 4, rightly? Well, it's a deceiving one. This is what we're looking at. So I pulled everything out of the parentheses, and that's the heart of it. So how do we interpret that? Well, we don't interpret it as if it's negative 2. It's the negative of 2 to the second power. So technically this is equal to negative 2 times 2, which is negative 4. So the negative is kind of like outside of the product. I know, it's weird. But if we look at it with the parentheses around the negative 2, now we have to interpret it differently. Now this is saying I want you to square or to raise to the second power negative 2. So this is equal to negative 2 times negative 2. Because you're multiplying two negatives, you do get a positive 4. So it's very touchy. If those parentheses are not quite in the right spots, you can interpret it a couple ways. So you got to be careful. So in this case, we want the first version, which says it's negative 4. So what can you guess about this one? Yeah, it's going to have to be negative as well. So we want to do this multiplication before we do the addition, and we can't do this multiplication yet because we got to figure out this answer, which we already know. Okay, so 2 times negative 5 better be negative 10 plus the negative 3 times the negative 4. So again, that was negative 4. all over negative 3 to the second, which is similar to the top here. So this should be a negative 9 over 9. Okay. Probably saying, something's fishy here. All right, so negative 10 plus negative 3 times negative 4, better be positive, so we can lose the parentheses. Negative 9 and 9, don't they just cancel, right? They do. It's going to be equal to 0. So let's just do the last step and simplify the top. Negative 10, positive 12. Subtract, we get 2, and it should be positive 2. So we get 2 over 0. So is that equal to 0? No. 0 has to be on top, and then it's equal to 0. If it's on the bottom, it's undefined. So, yeah, be careful of those cases. If 0 is on the bottom, it is undefined. If it's on the top, then it's equal to 0. So, okay. So that wraps up some order of operations stuff. Now, some of the properties that are involved, which we kind of take them for granted because we just kind of know that, oh, well, I can multiply things differently or I can add things differently. But there's got to be rules that dictate why we can do that. So that's what we're going to see right now. It's just some of the rules that you kind of already know. Okay. Now, the first rule is kind of a really, really, really silly rule. If A and B are real numbers, A and C, then the following properties hold. So this says that A plus B and A times B are real numbers. So basically, if I have two real numbers that I'm starting with and I multiply them together, or if I add them together, I'm going to get another real number as an answer. And you're probably saying, well, duh, what else are you going to get? Well, I know it is a duh answer, but in higher math, they like to have these rules. So yeah. Okay. So that one's kind of a silly statement, but it makes sense though, right? Okay, what about these next ones? Commutative properties. So this says that if I have A plus B on one side, that's equal to B plus A. So basically I can flip-flop them around and it doesn't change anything. Same thing with multiplication. If I flip it around, it doesn't change anything. If I say 2 plus 3, that's the same as 3 plus 2. So yeah, another silly one. But the big thing is the word commute. When you think of the word commute, you're traveling. Well, that's what's happening with this property. Sorry. The numbers are traveling. They're moving around. So that's how you can relate those two, relate how that property works. The next one is the associate property. So this one's working with three numbers. So if I said, okay, I got A plus B plus C, I can tackle this two different ways. I could say, okay, I'm going to group together the first two numbers and then I'll add the third one. Or I could group together the last two and then add the first one. The big thing you'll notice on both sides of the equal is that the order of the letters, or order of the numbers, technically is what they are, don't change. It's still in the same exact order. And the same idea for multiplication. And like I said, you could use an example, 2 plus 3 plus 5. You know, I could group together those two together and I get 5 plus 5, which is 10. But if I said 2 plus 3 plus 5 like this, okay, well, this is really 2 plus 8. It's still 10. So it really doesn't matter where you put those parentheses as long as it's all addition. That's the key, or all multiplication. Otherwise, it doesn't work. So, okay, so that's three properties. There's three more. So we got the identity properties. So there are real numbers 0 and 1 such that A plus 0 equals A. So if you add anything to 0, it doesn't change it. All right, we already knew that. And if you add 0 on the other side, it still doesn't change it. Same idea for 1. If I multiply anything times 1, it doesn't change it. And if I multiply 1 times anything, it doesn't change it. So we already knew those. So this one, though, you got to be careful because it gets confused with the next one. This one says that there are real numbers negative a and 1 over a such that if I add a and negative a together, I get 0 out of it. Or if I reverse it and add it, I still get 0 out of it. So it's similar to identity, but it's not quite the same because this one's using 0 and this one equals 0. I'll get it there eventually. So equals 0 or uses 0 equals 0. Uses 1 equals 1. So that's how you can kind of keep those two properties separate. It's easy to get them confused though, so be careful. The last one is the distributive property. And again, this one's a very important one. This one involves both multiplication and addition. So if you're taking a, which is a number, remember, and multiplying it by the sum of two numbers, you can do it that way and simplify the parentheses first, or you can distribute this a to both the b and the c. So a gets multiplied by the b and a gets multiplied by the c. So it's kind of a cool thing. And you can reverse it, or you can distribute backwards essentially. So the a gets back distributed to the b and back distributed to the c. But it's still the distributive property though. Okay, so now this last example is just kind of showing you some examples and you got to match it up with the right property. So what property is being illustrated with this one? So what is key thing that you notice in that? The numbers aren't moving. The numbers aren't moving. So you got the same exact numbers on both the left and the right side of the equals, but the parentheses are moving, not the numbers. So this has got to be the associative property. Okay, what about this one? Well, we're adding these two numbers together and we're getting 0 out of it. Remember, if you get 0 out of it, that is the inverse property. So this one should be inverse. And then 6 plus 9 equals 9 plus 6. Numbers are moving. If the numbers are moving, they're commuting. So this is the commutative property. All right, what about this one? Negative 1/4 times 1 equals negative 1/4. It's using the 1. It's using the 1, so that's identity. So this is identity. Oops, helps if I can spell. So identity. Boom. All right. And now what about the last one? 12 parentheses a plus b equals 12 times a plus 12 times b. Yeah, you can get that one. Anytime it has both multiplication and addition, and then or multiplication and subtraction as well, that would be the distributive property. So, boom. All right, so that is that question. So not anything too drastic, but you just got to be careful. Those properties can be a little bit tricky at times. So, all right, so that wraps up 6.2. So keep a lookout for videos on 6.3. See you soon.